Seaborn is an extremely popular visualization library for Python. It makes it really easy to create great visuals, even with a single line of code. So what we want to do is take a look at some examples in Seaborn, and if you want to follow along with the code, a link will be on this page. So in this Jupyter notebook, I've got several examples of Seaborn that we're going to walk through. And if you want to go beyond this, to learn more about Seaborn, a good place to go is to their official documentation, which is linked to here. All right, so what we're going to do first is we're going to import the libraries that we need. So we're going to use pandas in this case, another Python library, to load in our data. And then we've also got to import Seaborn. And the way that I'm going to import this is to say, okay, I want to pull in Seaborn, but I'm going to refer to it as this alias, SNS. So anytime I need to refer to Seaborn later in the code, I just use that. Also at the start here, what I'm going to do is I'm going to use set a Seaborn style. You can think of this as like setting a template in PowerPoint or Microsoft Word. And the style that I like is dark grid. This is not something you have to do. Again, it's just like adding a template. So what I'm going to start with is I'm going to go ahead and run this cell of code so I load in those two libraries. Now what I'm going to do is I'm going to read in my data. I'm going to use pandas to do that. And I've got a separate video on pandas which provides you a good overview of that. Now this data is data about customer churn. So we have information about all our customers and whether or not they churned. Churn means whether they left and are no longer using our service. What I want to do before I start visualizing this data with Seaborn is to preview the first few records so I get an idea of what it looks like. I got to know what I'm working with. So I've got customer IDs, the gender of the customer, whether they're married or not, whether they have dependents or children, whether they're a senior citizen, they're above a certain age, what their tenure is, so the number of months that they've been a customer with us. I've got whether or not they have phone service with us. It's yes or no. The type of internet service they have, if they do, it's either DSL, fiber, or it'll say no if there's no internet service. Whether they have paperless billing, what their contract type is. So this could be monthly, so month to month, annual or biannual. The type of payment method that they use, their monthly charges, and whether or not they churned. Yes is they churned and they left the company. Ideally, we'd like all of our customers to stay with us as long as possible. So let's try first to use distribution plots in Seaborn. So the way that I'm going to refer to Seaborn plots is I'm going to start with SNS because that's how I imported the library. I use that alias. And the distribution plot is DIS plot. Okay. And then what I'm going to tell Seaborn is that my data frame is df churn. When I loaded my data in, I put it in that data frame. It's a pandas data frame. And what I'm saying is that I want to plot monthly charges. It's going to give me the distribution of monthly charges. So I'm going to go ahead and run this. And I want to mention too that I've commented out several other examples. And so you can kind of see what small adjustments of the options of these charts, how that changes the way it looks. So I'll go ahead and run this. And I see for monthly charges, which is on the x-axis, I see the spread or distribution of them. On the y-axis, we're looking at the number of customers. So we've got a lot of customers that have fairly small bills, kind of like in the $20 to $30 range. And also a lot that are sort of in the $75 to $110 range. Okay? So it gives us an idea of the spread of the data. Now I could adjust this distribution plot so that I change the kind of plot. So in this case, I'm going to try KDE, which is kernel density estimation. It's going to represent the probability distribution curve, the continuous probability distribution curve. And so if I run this, it's going to look like a smoothed out curve. Somewhat similar to the last plot, we still have monthly charges on the x-axis, but it's the density on the y-axis. Now if I change this even further, what I want to do is add a fill-in. So if I say fill equals true, that's the only adjustment that I'm making here. It's just going to fill in underneath that curve. I can also make a different adjustment here to add some dimension to my plot. And what I'm going to do is I'm going to use what's called hue. So hue is for color. It's going to color my plot based on some other thing. In this case, we're going to use a category. We want to color based on the category of internet service, whether they have DSL, fiber, or no service with us at all. And so I'm going to go ahead and run this. And here's what it looks like. So I still see the distribution of monthly charges, but it's now added color for me. So those who do not have internet service, they tend to have much lower monthly bills, which makes sense. They maybe just have phone service with us. Customers who have DSL, that's in blue, they have higher bills than those without internet service, but lower bills than those who have fiber, which is this final color here. So it gives us an additional dimension there. We can look at the color or the hue based on some category, in this case, internet service. Okay, what I want to do now is maybe make one more adjustment. So I'm just going to use still monthly charges. Hue is going to be internet service, like it is down below there. I'm going to change the kind, though, to KDE for kernel density estimation, and the fill is going to be true. So it's going to look like one of my previous charts. I'm just coloring it out based on the type of internet service. So that's some examples of the distribution plot. Okay, now let's try count plots. So count plots are going to count categories. Okay, categories of data. It's not numeric, we're counting categories. So with the contract type, the different types we have are monthly, annual, or biannual. And so maybe I want to count up the number of customers that have each of those contract types. So if I go ahead and run this, I've got now counts for every contract type. There's a large percentage of my customers that are month to month or monthly. I wanted to mention here too that the actual syntax looks a little bit different for this plot. It's not like you have to memorize this. If you're looking for a specific plot, you can go into their documentation, just kind of make sure you got it right. They're all not too different, but anyway. Okay, so now let's try the next count plot. I just want to make a couple adjustments to this. So I'm going to add a hue like I did with my distribution plot, but I'm going to color it based on whether or not they churned. So what I want to know is by contract type, how many customers churned. Maybe there's one contract type where they tend to churn more often. Yeah, this is interesting. You can tell with annual and biannual, there's a lower percentage of customers that churn. And the reason for that is they only have one opportunity per year or every 2 years to get out of that contract. With monthly customers who are month to month, there's much higher churn because they can leave after every month. And so that hue is based on churn there. That's what you see in the legend. We still got contract type on the x-axis, count on the y-axis, but it's just adding that additional color there. Okay, I can also change this a little bit. So that instead of vertical bars, I can have horizontal bars. So contract type is on the y-axis. So all I've done is I've changed x equals contract type to y equals contract type. And when I run that, I'll see horizontal bars instead. So it kind of depends on how you want to look at it. I can add one more additional item here too. I could say that I want to add a palette, a color palette. So Seaborn, if you look in their documentation, they have lots of possible color palettes. This is kind of like we have in Microsoft Word or PowerPoint. I'm going to use the palette that's called Set 2. And this just gives me a different color. I can change the color scheme if I'd like to do that. All right, so those are count plots, counting categories. Now let's try box plots. And what I like to do is just go ahead and display this box plot so you get an idea of what it looks like, and then we can start talking through it. So I'm telling Seaborn, okay, use the box plot. I want that type of visual. And on the x-axis, I want the payment method. That's some category. I've got to have a category in a box plot in addition to numeric data. And then on my y-axis, I'm going to have monthly charges, okay, right over here. Now what this is showing us is kind of shape and variation in a set of distributions, not just one. So monthly charges was one distribution. We're looking at several because we split it up by payment method. Okay. Now I can adjust this slightly to use something called the violin plot. There's several plots that are somewhat similar to this, and I get an idea I look at it sort of in a different way there. I want to go back to the box plot though for a second, so to talk about what some of these things mean. So the line in the middle of the box represents the median. So the median monthly charges for customers who pay by check is like $37 or $38 maybe. And that median is far lower than the median for customers who pay with e-check. Okay, it's interesting. And then the size of the box represents the spread or the variation in the data. And it looks like there's more variation in customers who pay using automated credit than those who pay with e-check. It's a wider box when it comes to credit, automated credit. Okay, so I can also adjust this box plot a little bit so that maybe I'll use phone service instead. And I'll still stick with monthly charges, but I want my category to be phone service instead of payment method. So it looks like customers who have phone service, their median monthly charges are much higher, and I see more variation than the customers who do not have phone service. Maybe they just have internet with us, DSL or fiber. I can also adjust the box plot a little bit further so that I add some additional color to it, another dimension, whether they're a senior citizen or not. So I've used hue to designate that, like we've done in a previous chart. So I'll go ahead and run this. And what this is showing me now is I'm still seeing my monthly charges. I'm also seeing phone service, yes or no. But within each of those phone service categories, I see additional breakouts by whether they're a senior citizen or not, whether they're of a certain age. And so it looks like senior citizens who do have phone service, there's less variation in their monthly bills. Customers who are not senior citizens and do have phone service, they have a lot more variation there. A lower median too, it looks like. Anyway, that's another way to kind of look at the box plot. Now to try a couple other plots, I want to actually pull in a different data set. So I'm going to look at data for advertising spend. And what I'm doing is I'm storing that data in a data frame called DF ads. It's a pandas data frame. And so when I refer to the data up above, it was DF churn. That's the name that I gave it, my pandas data frame with my churn data. When I pull in this advertising data, I'm going to store it in this data frame. And so when I refer to, when I generate charts later, I'm going to use that name. But what I first want to do is just preview the first few records in the data so I get an idea of what it looks like, and it improves my ability to chart it. So I see in this data set TV, radio, and newspaper ad spend, and that's in thousands of dollars. And I see sales in millions of dollars at the end of this. And so the first three fields, you can think of them as like my inputs, what I tweak, and then sales is what my output is, hopefully. And each row maybe represents a different week or month or a different advertising campaign or something like that. Okay, so what I want to do now is illustrate some scatter plots. Okay, let me go ahead and run this so we can talk about it. So scatter plots show us the relationship between two variables, numeric variables. So what I did was I said, okay, Seaborn, I want to use scatter plot. And on my x-axis is going to be TV, advertising spend. On my y-axis is going to be sales in millions. The ad spend was in thousands. And here's going to be my data. That's the data frame, the pandas data frame that I loaded my data into. And it looks like there's sort of some relationship between these two variables. It looks like as TV advertising spend goes up, sales tends to go up as well. And this is showing us correlation, not showing us causation. Just because there's a relationship doesn't mean that TV advertising spend is causing that increase in sales. There could be other things happening. Okay, let's do this. Let's try to adjust our scatter plot a little bit. So in addition to showing TV ad spend and sales, I also want to add radio ad spend. And the way that I'm going to do it is I'm going to change the size of the bubble based on the amount of radio spend. And let me run this so it makes a little bit more sense. So each of these dots represents a different week or a different campaign. And I look at a dot and I can see the TV ad spend, I can see the sales, but based on the size, I can also see radio advertising spend. It adds that additional dimension. And maybe even a better way to look at this is to also color those dots to get a better sense of how much radio ad spend there is. And so what I see is still the size is radio spend, and the hue is radio spend as well. And so a darker dot represents more radio spend. It's the same with a larger dot, more radio advertising spend. Okay. All right. We could also look at, I could change this so I look at newspaper ad spend instead of radio spend and just see how that changes things. Let's try one more plot, the pair plot. And so what I want to do is first just run this to get an idea of, show you what it looks like. It typically takes a few seconds because it's generating multiple plots, not just one. And so this is going to show us several scatter plots and several histograms. And so I'm using my ads data again, and I'm going to go down to the bottom of this so I can kind of explain this more easily. But what this is showing us, at the bottom is for all of these three charts, actually all four of them, sales are on the y-axis and something else is on the x-axis. So TV advertising spend, radio spend, newspaper spend. And at the end here, it's just showing me the spread of sales. So this gives me, makes it easier to generate scatter plots. Maybe I want to look at a lot of scatter plots at once to be able to compare them. And I just want to write them with one line of code. Now, one issue you may run into as you're generating the pair plot is you can only feed into it numeric data. So if that's the case, what you can do is just adjust your code here so you designate a specific position. So what I'm going to say is I want a specific position in my data set, in my ads data, and in this first portion on the left-hand side, I'm just going to designate my rows, and I've left this just as a colon because I want all my rows. I don't want a specific subset of them. And then what I'm saying is maybe I want column 1 and column 2. Now what's a little bit confusing about this is it's actually going to give us column 2 and column 3 because this index starts at 0. But the way that I can do this is I can designate specific columns that are numeric, because if I try to feed it or throw it in columns that have text data in it, like whether they have internet service or not, it's going to throw an error. So you may have to designate the columns you want in your pair plot. So if I go ahead and run this, I should see just 2 columns, and it's actually the second and third column, again, because when I'm referring to it, it starts at 0. The index starts at 0. All right? Now, if you want some additional ideas of Seaborn plots, go ahead and refer to their documentation. It gives you a lot of great examples there, and it gives you the syntax you need for each of them.